In this video, you'll learn everything you need to know about electric current. In this video, we're going to be looking at what we mean by electric current. So the first thing to remember is that when we talk about current, what we are talking about is moving charge. Now, lots of particles have charge. Charge is quite a mysterious idea, actually, so we won't go into that in too much depth. We know there is positive charge and we know there is negative charge. Some particles carry positive charge, for example, protons. Some particles carry negative charge, for example, electrons. When any of these particles that have charge are moving, we can say there is an electric current. So, for example, if we had some moving protons, we could say we have an electric current. Now, that would be a fairly unusual example of an electric current, but it would technically still count. 9 times out of 10, more than that, when we're doing the GCSE course, what we're usually talking about is moving electrons. So electrons carry charge, so if there's moving electrons, therefore we can say we have an electric current. If we want to be more precise, what we really should say is that current, rather than just being a flow of charge, current is actually the rate of flow of charge. So what does that mean? It literally means how quickly the charge is flowing. So the equation is simply electric current equals the amount of charge that's passed by a certain point, could have been carried by electrons, could have been carried by protons or whatever, divided by how long it took for all that charge to pass. Now, charge is measured in units called coulombs, and coulombs has a capital C. Time is always, well, nearly always, measured in seconds. So that means current is measured in coulombs per second. But nobody really says that. What we do is we abbreviate it and we measure current in amps and we give it the symbol capital A. If you want to write that equation as symbols, we say I for current equals Q for charge divided by time. So how do we measure current? Well, very simply, we measure current using an ammeter. So you can see an ammeter there in the diagram. It's literally just a circle with an A in it and the wires coming out of it. So we can write here, current is measured using an ammeter. Now watch the spelling of this, because a few students call it amp meter. Understandably, because obviously it does measure the units amps, but its name is an ammeter. And you just place that anywhere in the circuit and it will tell you how many coulombs every second are flowing. One important point about current is that it doesn't actually run out. The charge doesn't ever leave or enter the circuit. The charge, the electrons in this case, are already here inside the wires. Okay, now the battery itself, the cell, that contains energy for sure. But the actual electrons are inside the wires and they don't run out. What happens is when the circuit is flowing, we can say that the current flows all the way around like this. It goes around the wires and just keeps going round in a cycle. This side of the cell is called positive. It's always the longest side. That's how you can tell. This one's negative. And we always draw electric current as though it goes from positive to negative, even if we know electrons won't actually do that. But that's for another video. So let's look at our electric current flowing around the circuit. Let's say it flows around this way, flows around and goes all the way back to the cell over here. Well, if this ammeter tells us that it's 3 amps, so that would mean there are 3 coulombs per second, that means the 3 coulombs per second are going around the wire, passing through this light bulb here, and are coming back again, which means this one must also have 3 amps. So current doesn't run out. In fact, it's the same all the way around the circuit. Whilst current can't run out, it can split. If we imagine that the electric current is travelling around the circuit like before, when it gets here, some of it can go this way, some of it can carry on and go this way, and then it will recombine again as it gets to here. You can think of it a little bit like water in a pipe, in that the water doesn't actually leak anywhere, but it can split into separate pipes and then recombine again. So it's quite simple, really. If we were to imagine that this was, let's say, 5 amps, or 5 coulombs every second, we know absolutely that this one must also be 5 amps, because if 5 coulombs per second are moving round here, then 5 coulombs per second must be moving round here. Let's say that passing through this bulb we get 3 amps. Now at this stage, don't worry why it's 3 amps and not 2.5 amps or something like that. Let's just imagine that it's 3 amps flowing through there. Well, we know for an absolute fact that this one must say 2 amps, because the 3 amps, the 3 coulombs per second, and the 2 coulombs per second, the 2 amps, must recombine again to make a total of 5 amps. So once again, the current does not run out, but it can split. Hopefully that's the basics of current covered. If you want to know more about electricity, including voltage, check out some of the other videos, and please do consider subscribing to the channel.